Good morning. I come to Denver quite often to work with one of my partners that's located out here, but they're out in the tech center, so don't get a chance to come downtown for more than a couple of hours. It's been good to spend a week downtown. Hope you're all having fun, learning something in the conference. So you're busy at work one day, and some big strategic thinker from business development comes by and says, you know, we really need to scale to millions of users, the web and everything. Anyway, he goes off, and you start thinking about it. Well, maybe not millions, but certainly want to scale to hundreds and thousands of users on some of these large Intel boxes that are out there. Well, what actually does that mean? Can you just drop in hardware and be done with it? Or are there actually some best practices that you should employ to make your application perform well and scale to the large number of users? My name is Filo D'Souza. I work in the SQL Server dev team on the ISV team. We work with software partners to work on joint new features, to do some stress testing, and also to work on performance in terms of both performance and scalability. We look at how their applications interact with the back-end SQL Server database, make performance improvements continuously during our development cycle, and try to come up with some best practices. I hope to give you some insight today in how to build high-performance scalable apps and maybe reinforce some of the practices that you're already using. We spent a lot of time, as I mentioned, working with the application partners to better understand how their application suites actually work. And these are really complicated suites in many cases. And we want to understand what the characteristics of these are with respect to performance and scaling. I purposely mentioned both performance and scaling. So think about performance as the amount of time or some other metric that you might be using to get answers to a specific query or specific batch job. Scaling actually refers to the number of concurrent users that you can have on the system at any one time. By working with our partners, we have broken down some of the issues into trying to address some of the bottlenecks. What I'd like to talk to you today about is how your application can best interact with SQL Server, or what the tips we are and some performance characterizations that we've determined going into SQL Server 2000. In this conference, we are introducing the building blocks for, and a couple of weeks ago with the Windows 2000 announcement, the building blocks into WinDNA 2000. The SQL Server 2000 piece is actually for the structured data, the RDBMS behind WinDNA. A major design philosophy anchor in SQL Server started in SQL Server 7, basically was for self-management of the database system based on the requirements that the users were putting on the system and the resources available. This takes the form of self-configuration, management, and tuning. So memory is a dynamic resource. The buffer pool, its associated data structures, all other requirements on memory automatically grow and shrink as they're needed, given that there are resources available on the system. This is very tightly coupled with the NT memory manager so that we can get and release memory quickly and efficiently. We have dynamic locking. Well, that basically means if you're doing an OLTP application like order entry, you want to be getting row locks so you can maximize concurrency. On the other hand, if you're doing DSS, you want to not be constantly getting locks and using resources in the system, and you might be using page level locking or escalating up to a table. Well, this is all done automatically at runtime by the SQL Server engine. We also do automatic statistics creation. So if you've got columns that are used in a query that are not part of existing indexes, we can auto-create them on the fly. We will also notice that new data is being added to the system and automatically update them. Both these options work very well, are very efficient, but if you want, you can turn them off. We have file groups that allow for logical grouping of files. I mean, it's invisible for low-end implementations, but for high-end implementations, it scales very well. It allows you to have multiple parallel scanning, take advantage of interquery parallelism, and things like that. These are all great features when used in production. However, you're building applications, so what actually affects you? I want to talk about what you can affect directly from an application development standpoint and to get optimal performance and allow scaling of a large number of users. First, I want to talk about the plan cache, how it works, the various methods, performance implications, and our recommendations. The second topic will be cursors, what they are, the effect on system resources, implications of using them, and our recommendations again. Throughout both of these, I will be talking about the performance enhancements we introduced into SQL Server 2000. Please note that this week, many of my colleagues have talked about a lot of performance improvements, whether they are index views, improved statistics, better plan improvements, parallel scans, merry-go-round scans, things like that. So there's a lot more than this that went into performance improvements in SQL Server 2000. What is the plan cache and why is it important? So SQL statements are taken by the command parser, checked for syntax, and then broken down into an internal format called query tree. The optimizer will take the query tree and prepare for execution by compiling and optimizing it. The first step is to normalize this, basically breaking this down into individual smaller requirements. And then it tries to optimize it, basically produce the most efficient plan for getting at the result set. In SQL Server 7, we introduced a brand new cost-based optimizer. Basically what this does is it tries to minimize the resources required on the system to implement the query. So starting with reducing the number of I/O requests that it needs, the amount of CPU processing that is required, and the amount of memory that it's using. It looks at the amount of data in the tables involved, all the indexes that are available to it, and the distribution of the data within those tables. Keep in mind that it will also prune heuristics, which basically means not spending too much time optimizing it compared to the relative cost of actually executing the query. After optimization, an execution plan is generated and stored in the plan cache. The query plan is re-entrant read-only data structure, which basically gives the instructions of how to progress through the tables, the indexes, and what the selection criteria are for the criteria. Well, why is this important? The execution plans are stored in a plan cache. When a subsequent query comes in, it's going to do a lookup in the plan cache. If it's already there, well, there's no need to compile and optimize it. It's found it, and you've got great savings on CPU resources. For non-trivial SQL statements, this could be a big savings. I work a lot with the ERP suites out there, and for some of their more complicated statements, you can see that the compile time could cost just as much or even more than the cost of actually executing it. There are techniques that both the system and you as the application developer can employ to make better and more efficient use of the plan cache. In other words, to use the post-optimized plans that are already in the cache on subsequent queries so they don't have to be recompiled. The two techniques that we use internally in SQL Server are ad hoc caching and auto-parameterization. You got to understand that these are very conservative in nature. We don't actually know your intention behind the application queries and have to take a conservative approach. As the application developer, you can, and knowing your application and the queries, you can make better use of plan caching for your defined workload with the use of store procedures, exec SQL, and prepare execute. For plans to be sharing, you got to make efficient use of the caching mechanisms. So ensure that all users execute in the same environment, same DB options, same SP configure and set options, as well as you don't want to do implicit resolution on queries. So ad hoc caching, this is the most simplistic case performed by the system. Basically, it's an exact textual match. So in this case, query 3 is going to use the plan from query 1. Query 2 will need to be compiled. As I said, this is very simplistic and it's barely useful in a well-defined application environment. The next means of parameterization by the system is auto-parameterization. This is done only for simple queries. SQL Server is going to make a very educated guess on what it believes in a conservative manner are the constants and literals involved. So for example, select last name and salary from an employees table where it's employee 1000. It would probably make 1000 into a parameter. On a subsequent execution looking for employee number 2000, it would use the plan. Please don't rely on auto-parameterization or ad hoc queries for your defined workloads. So just to give you the scope of what the forms of auto-parameterization are, insert into table various values. It could be a constant or a literal, a null, or a default. You can delete from a table and you'd have a key expression, either a constant, columns, and operators, and less than equal to. You can update and set a column, again using a key expression, and you can select from the table with the key expression in order by some of the columns. So I mentioned a simple example where you're getting the name and salary. I don't have salary here, but for instance, this is a safe parameterization. The second example is where it's not safe and we won't build a parameterization template. So we're selecting where the salary and bonus is greater than 30,000. Well, if you try to parameterize 30,000, if the next query is 80,000, you could have a drastically different result set and probably might have a different optimal execution plan. So unless SQL Server can deterministically determine that for all ranges of parameters, it would have the same optimal plan, it's not going to parameterize some of this. And this is done through interaction with the optimizer. I'd like to talk briefly about store procedures. Basically, as a general rule, all well-defined SQL Server applications tend to make good use of store procedures. The SQL statements are compiled into a store procedure and it saves a considerable amount of compile time at execution. They can return a result set, parameter output, or a cursor variable. So the calling application doesn't need to transmit the entire query to the server. It's there. It's a persistent object when you create the store procedure. All you need to do is send the name of the store procedure and the parameter values down to the server when it needs to be executed. Keep in mind there's a with recompile option. What this means is each time it's executed, the SQL Server engine will recompile this to get a new execution plan. This is to be used if on different invocations of parameters you can have widely different result sets. If you're going to generate dynamic SQL within a store procedure, there are a couple of options that you might have. Basically, if if you're going to be changing the SQL drastically, the table names, the column names, things like that through dynamic the statements within the store procedure, consider using the exec string. If you're just going to be changing parameter values, use the execute SQL so that you're just passing in parameter values. If you're going to be using dynamic SQL within a loop, you want to use exec SQL if there are going to be parameters passed in, so that you only compile once. With an exec string, you're going to be compiling through once each loop of the store procedure. So store procedures can help you in having a consistent implementation of your business logic. You build it once, you test it, and it's run. Your application suite just calls it. Another general rule that you want to take a look at is keeping your business logic very close to the data. And you can see this for critical business logics like generating a next numbers. Why would you want to go all the way back to the client when you can do it in a store procedure on the server without the round trip to the client? It minimizes network traffic and avoids parameter processing. In addition, you might have some conditional logic within a particular business rule. So you would invoke subsequent SQL statements as a result of the first or initial SQL statements. Well, again, why would you go all the way back down to the client to apply that conditional logic? Put it in a store procedure up on the server and execute this once. Others have discussed user-defined functions this week. Basically, they return result sets and are can provide similar effects to store procedures. Think of exec SQL as halfway between ad hoc and store procedures. They're very similar to store procedures, but they're created on the fly by the application. There is not a requirement for persistent object management. So from the example before, repeated calls with the same batch will use the cache plans. And in this case, the cache plans will be used for all three statements. For ISVs that we worked with previously, we've indicated that you should use this method if you don't know that you're going to be executing the statement more than once. So this is one round trip to the server to execute. This is exposed in ODBC with SQL exec direct and in OLADB with iCommands with parameters. Prepare execute is another method that we encourage application developers to use for effective use of the plan cache. Consider an application using one connection that's consistently executing many times. This could be a payroll application, for instance. Prepare execute is like exec SQL in that you are purposely parameterizing the statements, but it doesn't require the full text to be sent down all at once. You prepare this once, and a handle is given. On subsequent executes, you just pass in the handle and the parameter values. ODBC and OLADB expose this as SQL prepare, SQL execute, and iCommand prepare. The trade-off that you're going to have here is the handle can only be used on the one connection that it was prepared on. Before I get into good news in SQL Server 2000, I wanted to quickly talk about an issue, inappropriate plan sharing. So we are very conservative when using auto-parameterization. For the other methods, the application developer takes responsibility for parameterizing their statements. So when we first compile the plan, it's based on the default parameters that are sent in. If a subsequent execution uses parameters that would have a very wide range, can return a very different result set, it might not pick the optimal plan. So take a look at this example where in the first case you might do an index lookup, And depending on the data distribution, in the second statement, you might do a table scan. So the optimal plans are not there. This is a responsibility that the developer takes when parameterizing. So working with the various software partners, we've always had this issue. When do you use exec SQL versus when do you use prepare execute? Well, many of you support more than one database system and tend to have a database driver isolated from your application code. How do you pass what the intent of the application in the application layer wants down to the database driver? Do you do special casing? Do you pass hints? Is that even possible? And basically, you're trying to predict usage by the user. Well, what about the case when some of you have three-tier application implementation? The app server now has to guess what's happening on behalf of the client machine. So our advice always was, if you're going to, on one connection, invoke multiple executions, you should use the prepare execute model. Keep in mind that there is an n+2 costing in terms of round trip. You've got to prepare, then all the executes, and then unprepare. If you were only going to do this once, we would suggest you do an exec direct. Many developers were frustrated with trying to come up with an algorithm for figuring out when to use exec SQL versus prepare exec. So we made a major effort in trying to resolve that in SQL Server 2000, and I believe we succeeded successfully. So for both OLADB and ODBC, we have managed to reduce the number of round trips. This happens only if all the parameters are specified in advance. So you bind before you prepare, and you don't request the metadata between the prepare and the execute. So describe call in ODBC, for instance. What's happening is the driver manager is going to cache some of the statements. So when you first do a prepare, the driver manager is not going to RPC to the server to prepare the statement. It's going to hold it back on the client. It's only on the first execute that the prepare is piggybacked on the execute. It goes off to the database server, which prepares the statement, provides a handle, and comes back to the client. You would execute, you do an execute one or more times. When you go to unprepare, the driver manager is then going to hold on and not RPC to the server. It's actually going to wait for the next prepare of a subsequent statement. So now instead of a minimum of 3 round trips, you can do this in 1 round trip given the 2 requirements that are specified. This is really useful in a benchmark environment, but actually it turns out to be much more effective in a WAN environment, a real-world environment, because all these reduced round trips will actually save you when you've got clients sitting across an enterprise. Although metadata is very critical, it can be considered overhead. So when we looked at performance and scalability, we took a hard look at what we were doing in terms of metadata and found out that we could optimize some of this without affecting any functionality. Many of you do a large number of selects that result in a singleton result or a small number of rows. If you're bringing back all these columns on wide tables, well, the metadata associated with all these columns is quite large and proportional to the data that you're actually getting back. And the cost can be quite large, 10% for a medium to large size table. We optimize this by caching the metadata out on the client. So the first time, this is when using the prepare execute model, which I've just recommended that you use. The first time that we do this, we get all the metadata back and cache it, and we will set a flag. So on subsequent selects, you don't need to send the metadata back. This is all automatic when you use prepare execute in SQL Server 2000. Some applications have tables with very many columns. Consider the case where you're doing a lot of insert work and the processing of all the parameter data could be expensive. up to 30% of the total cost for tables with a large number of columns, sorry. When using prepare execute again, an object is actually constructed that takes the information off the wire and is cached on the server. So on subsequent executions, the client driver indicates that the metadata is not changing. Keep in mind, your metadata is not going to change while you're running your application suite. It typically happens when you bring it down and update it. So the structured cache will be used on subsequent executions, and the only thing that's read and processed are the actual data values and the length of the data associated with those data values. A significant amount of processing is saved. So as far as the planned cache, what are our recommendations? Please use store procedures, especially for anything that affects scalability, next numbers, business logic, conditional logic. Use prepare execute instead of SQL exec. You will get the potential benefits without any additional cost. Please parameterize, ensuring that the range of values don't change drastically. And you want to pay attention to the sharing rules that I mentioned. So execute in the same environment and don't use implicit resolution. The second area of application development that greatly affects performance and scalability is cursors. Well, why would you use cursors? Well, it turns out most of you, again, support more than one database management system. And you tend to isolate the application logic from a database driver layer. And most of these database driver layers tend to use cursors. Another reason is that you might want to scroll and update within a row set and not have to provide the support yourself. You might also want to do multiple statements on your one connection to the database. And there's a possibility that even though you put a query for a result set, you might end up consuming a small section of the result set. And you might have your own independent reasons for using cursors. SQL Server is naturally set-oriented. We like to deal with row sets, and it's probably a mistake to use just an ISAM behavior. When you look at cursors, you can talk about server-side cursors and client-side cursors. Server-side cursors are implemented by SQL Server itself, while client-side cursors are implemented by the interface, ODBC or OLADB client libraries. So they support, the client-side cursors support many providers, while the server-side cursors are tightly integrated into SQL Server. When you're talking about high-performance scalable apps, you want a tight, clean conversation between the client and server, and that's why I want to talk about server-side cursors. I'm talking about cursors in a rather general form, counting the default result set as a cursor when it's typically not a cursor. As far as choosing to access your data in SQL Server, please always consider the low-cost options first. So the default result set and the fast-forward only cursor. If you have more functional requirements, then you would consider static, dynamic, and key set cursors. You want to take a look at the impact on the server and network resources on your choice of cursors. It's important to understand what the server is actually doing, the number of round trips you're doing, and the row set size. Please keep in mind that the way the cursor is going to be implemented is dependent on the isolation level that you specified. So for instance, on a repeatable read, we need to get a share lock as we're putting rows into the cursor. Well, if this is done in context of a transaction, those share locks are going to be held until the transaction is done. The first low-cost option that I'd like you to consider is the default result set, sometimes called a fire hose cursor. It's It's the most efficient and best option you have for getting data out of SQL Server. So we're going to compile the statement and start getting the, and then executing the compile plan. You're going to start pulling data out of SQL Server. What SQL Server does is it loads up the network buffers and pushes them down to the client, which is cached on network buffers on the client. As your interface fetches the next row, it's pulled out of the network driver by ODBC or OLADB. Keep in mind that you never have to put an RPC from the client to the server. As resources are available and it's efficient to do so, the server is going to be sending down the packets with the result set down to the client. And these, the rows are packed into the network buffers in a most efficient manner possible. The server also doesn't have to stage any data when it's implementing a default result set. So the major issue that you're going to have is from the time that you open the default result set till you fully consumed it, the connection is going to be busy and you can't use another statement. Fast forward only is an optimized fast forward read-only cursor that we've implemented on SQL Server. The major advantage that it has over the default result set is that it minimizes when the connection is busy. So from the time that you do a fetch next till the server sends you the data, the connection will be tied up. But from that time on till the next fetch next, you can use that connection for other SQL Server statements. Please think of fast forward only as a very thin layer over the actual SQL statements, unlike the rich cursor models that I'll describe later. It operates directly over the base tables and is read-only. At this point, I'd like to talk a little bit about auto-fetch. Auto-fetch is an option that you can specify on all cursors. What it basically does is when you open the cursor, it's going to get the first set of data and send it back on the back end of the round trip down to the server. And that will happen with fast forward only if you specify this condition. If auto fetch is enabled, auto close is also enabled. That means when you're fetching next and you exhaust the result set, it would automatically close the cursor. So think about the situation where you've got a small result set that's bigger than the result set size that you specified in the, as a buffer. On open, it's going to fetch the results automatically. It's going to exhaust the result sets, and it's going to close the cursor. So that's one round trip that you end up doing. In terms of performance, they're probably going to be a little bit more network buffers than Firehose. First, after the first auto fetch, on the client, you're going to have to do fetch next. So that's another round trip to the server. It's also probably not going to pack the rows as efficiently as Firehose because you're setting the row set size, and that might not correlate to the network buffer sizes. In most cases, fast forward only is slightly more expensive than the default result set. We're typically seeing 10 to 40% more expensive. But fast forward only is one of the two low-cost options along with the default result set. Static cursors basically are a snapshot of the answer set done on cursor open. They're materialized in TempDB at cursor open. It's read-only, and the underlying tables cannot be updated. It won't reflect any new rows or any columns that are changed in those rows, even if committed. All scrolling options are available, but obviously something like forward only doesn't make much sense. There's a significant impact on server resources. You are creating, populating, fetching from, and then cleaning up the temp table. This is very important. When we first started working with many application developers and their suites, we found a big overhead in populating static cursors. And it turned out to be bottlenecks when scaling to a large number of users. it turned out that most of the queries that they were doing with static cursors could be done with one of the low-cost models and greatly improve concurrency once the change was made. Key set cursors create a key set or the index keys in TempDB at cursor open time. The membership of the rows is fixed, although if the values of the columns are changed while you're fetching, you will see that materialized on the next fetch next. The actual order of the rows, though, are fixed, and that's why you're able to do fetch to an absolute position in the cursor. It requires a unique index in every table in the select, and when you're fetching data, it'll combine the index keys with the non-index columns. The performance implication is that you're still materializing keys in TempDB, and when you're doing a fetch, you are combining those keys with other columns in the table. Dynamic cursors operate directly on the base table, so all your scroll options are available except for absolute position. You can do fetch relative, though, so all the changes are visible when scrolling. Please keep in mind that there's a possibility that dynamic cursors are going to be downgraded, which I'm going to talk about next. The implication is that on each fetch next on dynamic cursor, you're going to be reapplying the select criteria. So you can see changes, but there's extra processing that's going on to satisfy the fetch requirements on a dynamic cursor. Cursor downgrade, or sometimes called implicit cursor conversion, occurs when generally you need to materialize the answer set on TempDB. So depending on the original request, whether it's fast forward only, key set, or dynamic, it could be downgraded. A common circumstance is when you request an order by that's not covered by an existing index. Well, to do this, we need a work table, and it's going to be probably downgraded to a key set or static cursor. Other cases are when you specify a top N condition, or if you're going to use aggregates in your statement, group by, union, distinct. Forward only, key set, and dynamic will all be downgraded or converted to static cursors. These are all documented in the SQL Server online documentation, but you've got to keep in mind that as the product is enhanced for SQL Server 2000 and into the future, this behavior can change as enhancements are made to the product. So the recommendation that we have for you is to always test. Look for potential downgrades by checking SQL Success with info. And you can do that in your development builds. You obviously wouldn't do this in production. So what really is the difference in performance between key set and dynamic cursors? Well, between static and key set cursors. Static cursors are going to materialize the entire answer set, but it's there on disk. So it's going to be the cheapest subsequent fetch. With key sets, the open will be faster because all you're populating are the index keys, but it'll be the next cheapest fetch because it does have to match up the index keys with other columns in the query. Dynamic fetches are generally more expensive as the original select condition continues to need to be applied. Another rule of thumb is regarding the number of tables. If it's only going to be one table, your dynamic cursor is probably going to be faster. When you're doing joins across more than one table, you're probably faster with static and key set cursors. Please note that for key set and static cursors, you can asynchronously populate the work table using the cursor threshold configuration parameter. You don't want to do this don't want to make this too small because it's most efficient if you do it up front and synchronously populate the answer set. We worked with a lot of application partners, and we understand that you make great use of cursors. So as part of SQL 2000 Continuous Performance Engineering, we took a long look at our internal implementation of cursors and came up with some performance enhancements available automatically in SQL Server 2000. The cursor compile plan contains statement objects, optimized plans. So for individual uses of a cursor, you need the individual runtime with the variables, the metadata, etc., which is used to create the cursor. Well, we optimize this by reinitializing and reusing this, so you don't have the get memory requirements. For the cursor execution plan, it's a representation that contains variables and the context data. We basically save this now, we reattach it to the proper context, reinitialize, and reuse. Fetch next being optimized for static and key set cursors. For both of these, you have a work table, and there's an index on the work table. In SQL Server 7, we asked for a range of values. In 2000, we asked for an unbounded range. But what this allows you to do is, on subsequent fetch nexts, you can move to sibling rows directly without needing to retraverse the index. A savings there. We optimize key set fetch. Again, there is a work table containing index values. As we process the query, you need to revalidate whether some of the column data is changing. We optimize the checking to check for timestamps and the actual RID data. The cursor footprint has been improved. You're going to see a 5 to 15% improvement in the footprint memory requirements of cursors, with key set cursors seeing the biggest improvement. So these changes are all automatic and come with SQL Server 2000 without changes required in your application. When we work with partners, it's apparent that many of you do a lot of select workload, and much of this, 50% or 80%, end up being singletons. So we focused on improving the performance here. Looking at this from the client side, basically what we can now do in the case of singletons is get the data directly from the network buffers into the application address space, saving 1 or 2 memory copies. We also speeded up the processing for column access to make that more efficient. Our interface folks, the guys in OLADB, looked at this as well and came up with the IRO interface. It allows you to quickly and efficiently get singleton result sets. So if you know ahead of time that your result is going to be exactly 1 row, you can use IRO. It processes the columns forward only across the 1 row object. If your result set ends up being more than 1 row, it's going to only expose the first row in the result set. From a general performance standpoint, many of the performance suites that we work on find that your inserts use defaults. Well, we speeded up the default processing in SQL Server 2000. We short-circuited the type checking and the initialization, which really doesn't need to happen with default parameters. In addition, when processing store procedures, the default values are retrieved once and then used from the local cache. So you're not always looking up the default parameters. In some workloads, we're seeing a significant improvement, for instance, 6%. The second one is speeding up batch processes, and this is actually an application optimization and little to do with SQL Server. Consider when you're going to be inserting many rows into a table. You could have a store procedure for inserting 1 row at a time, or you might insert, say, 5 rows. Well, what this does is it saves the setup of the store procedure and the lookup in the plan cache. So and the savings is about 10,000 instructions for this. So in the example that I gave you of 5 inserts, you could be saving 40,000 instructions with a shared insert. In SQL Server 2000, we also introduced a shared memory netlib for NT. Some of you run batch, or your applications have batch programs that run on the database server. Or you might have a 3-tier application configuration, which is run in a virtual 2-tier configuration. So the app server and the database server run on the same physical server. Using the shared memory netlib, you don't have to go all the way through the TCP stack. You can just use the shared memory implementation. So that's a big savings. Other people this week have talked about the system area network technology, ServerNet or GigaNet. These are high bandwidth native interfaces that you can use to bypass the TCP stack. It's very efficient. In some of the industry benchmarks, we've reduced kernel time by 1/3. Just want to quickly talk about connection pooling. So this enables an application to use existing connections in a pool and not have to reestablish a connection all the way to the server. I mean, this is straightforward if you're thinking about it from having an application standpoint, but it's also very useful from the client side. Say you have an order entry application. When you click OK, and the main thread is starting to process that, you can kick off another thread that might go and check inventory, and another thread that might go check financial considerations. If they use connection pooling, once the connections are created on the client to the database server, they stay around. So you don't have to continually recreate connections. Connection pooling is enabled in 3 ways. When a connection is requested, if there are none that are in the pool, it's created with the requested connection properties. If there's a free connection in the connection pool, it checks for the connection properties requested, the user ID and password. If they match, it will use that connection. If not, they will create one with the new connection properties. You can see some big performance gains because instead of having to create a connection going all the way to the server, you have a ready existing connection on the client side. So you save all the latency as well as the network round trip, and you save the CPU processing on the server for establishing that connection, which could be in the order of 900,000 instructions. We've worked with many ISVs on performance issues for SQL Server 2000 in many application areas. So these drove many of the optimizations that we put in SQL Server 2000. And the proof is in some of the numbers that we announced a couple of weeks ago in the Windows 2000 announcement. For instance, the SAP number on NT is 30% better than any competing database number. And the financials and the HR number for concurrent users is greater than any database on any platform for PeopleSoft. They all took advantage of some of the features that we talked about today. Prepare execution, taking advantage of the reduction in round trips, the SAN technology, optimizing for fast forward only, auto fetch, and the default result set, good parameterization, and very good use of store procedures. Just talk a little bit about scaling considerations. As you scale the number of users on your system, the resources that you need for individual queries or workloads is going to scale equivalently. So this can become a bottleneck if you constantly need to use server resources like materializing result sets for the rich cursor models. Also, if you have an ineffective planned cache usage, well, you're going to be compiling. I mean, what you really want to do with your planned cache is after a warm-up period, all the queries should be compiled and are in the plan cache. So you should see very little compiling going on once it hits a steady state. In terms of dynamic resources, well, the dynamic cursors and key set cursors are continually looking up data. You have processing and cleanup activities for some of these materialized answer sets. And if you're not parameterizing properly, well, you have all these unnecessary plans in the plan cache. When we look at network round trips, you want to look at the default result set and fast forward auto fetch, as well as looking at connection pooling. This is important in your testing and in the performance benchmark world, but much more important in the WAN environment where those round trips are very costly. So to summarize, work on making a strong plan caching mechanism. Use store procedures, especially for business logic and conditional logic, to have it all done on the server. Use prepare and execute now instead of exec direct. You get the benefits without the additional cost that you did in SQL Server 7. And always parameterize well. In terms of cursor, please use the lowest cost options that are available and make sure that you test for downgrade during your development cycle. The main message that we want to get here is many of these optimizations that we talked about, the improvements that we made in SQL Server 2000 are automatic. They're done in the SQL Server product and don't require action on your part. If you were looking for more information on these, you can take a look at our beta and the beta news groups. Some of this information is available on our homepage and in articles on the support site at Microsoft. Do you have any questions?
I've got it. I don't think this is on.
Oh, sorry. Go ahead.
Basically, two questions. One is, we could do store procedures, like say dynamically, like prepare and SP, execute SQL, but is there any future thought of doing it, say, using a structure, nested structure to store maybe the second or within the store, towards inside the store procedure? Now using a structured data type instead of just the regular parameters, or a dynamic type of.
I'm sorry, I can't hear the question.
See, basically, when you create a store procedures in your case statement, you basically pass a lot of parameters in.
Yes.
There's two questions I have on that. Is there any future direction of possibly using a variable number of parameters? And second is there any future direction as far as passing structures instead of straight parameters?
Okay. I would like to take that offline with you. I probably need to get into a bit of a discussion with you on that, if you don't mind. Sorry.
Everything I've ever seen about connection pooling mentions the ODBC drive. Do we get connection pooling through the native SQL Server ODB provider?
Oh, yeah, that's automatic and as soon as you initialize.
So way to go.
Yeah, you don't have to do anything special in OLADB, and that's why you don't see it documented.
Okay, my question is about auto stats. What's the performance hit on that? Because you said you can turn it on.
Okay, for auto stats creation and auto stats update, keep in mind that you can turn that up, but it's very, very efficient. We do a fast sampling, so even on the largest tables, we're seeing that it happens, in seconds.
Okay, and then user-defined functions.
Yeah.
How much of an overhead is that using those? Is there going to be a huge performance hit?
There really should not be. It's a persistent object on the server.
And my last question is about explicit resolution. Can you explain what that is?
Oh, select from table. You don't specify all the way down from the database name to the user to, so for instance, if Mary
I got you.
selects, okay.
My first question is there any way to turn off crude heuristics in the optimizer itself? So if I know that I'm going to run this query again and again, it's going to get cached. So I want to get the best execution plan. So even if I know that the time to compile will be more than time to execute, I want to take that hit.
In advance, there currently is, that's not currently done in the product. It's not externalized in the product.
Is there a trace flag for that?
I'm sorry?
Is there a trace flag that you are aware of for that? Second question is about, yeah, you said that in ODBC driver manager caches the prepare statement, the handle.
Yes.
Who does that if you're using OLEDB?
Sorry, ODBC and OLEDB driver manager.
Okay.
Yeah, absolutely, for both of those.
Okay.
They're both fully supported.
Okay. And my third question is, if I understand correctly, prepare execute is only useful when you parameterize. Is that correct? Is that right? Using prepare execute model is only useful when you're using parameterization. Is that correct?
Yes.
And about fire hose, does that mean no cursor at all, or?
You can think of that as a pseudo cursor, but it's not a cursor, correct? Yeah, it's just shipping the result sets back on network buffers.
And my last question about ILO in OLEDB, is there anything equivalent in ODBC for that?
There isn't, but keep in mind you can. It's very efficient in ODBC.
Thank you.
Thanks.
On your first slide that was labeled stored procedures, that you talked about SP execute SQL versus exec, and I wasn't quite clear on the difference there. Could you kind of restate that?
Okay, you can just execute a string within a stored procedure, execs select star from employees, as opposed to calling exec SQL. Each time you use an exec string, you're going to compile the plan. With exec SQL, the plan's going to be cached, and so you will reuse the plan.
Thank you.
In terms of using connection pooling, say right now I use ADO and connection pooling. My understanding is prepare exec is only per connection. So how can you get the benefit of the connection pooling and also the prepare exec performance improvement?
Well, you get the benefit if you are going to be executing more than once on the connection, the active connection.
Right, but usually the model, say it's a typical model, you do an operation, say on a web page in ADO, and then you close the connection. It's a very common thing. So I guess in that
in that model, you're not getting the advantage of the prepare execute model, but there is no additional cost with the changes that we made in SQL Server 2000 for using prepare execute.
Yeah, it almost seems like there should be some way, or it might be something to look into how you could kind of get, because a lot of times you're executing maybe the same query, but it gets spread across, all these connections, but you can't use the prepare execute.
Right, we can't share the handle across connections, unfortunately.
Right, but it's a very common scenario on the website. They're really all the clients are executing very similar queries over and over.
And I think we know that requirement. Thank you.
I'm sure you've seen a lot of cases where a client application is doing a fast forward only cursor, but they have neglected to change the cache size to anything other than the default of 1. And often the application would work 100% properly with a larger cache size, returning a larger number of rows. I've been in a number of situations where I don't have the ability to, for one reason or another, touch the source code. And what would be very nice would be a server or client side override, essentially, maybe at the DSN or EDL level where I could say change the default cache size from 1 to something higher than that, because I've been in dozens of situations over the past year where that would have allowed me to improve performance without having to touch source code.
That's a really good idea. I don't think we thought about that. I'll certainly take note of that.
Okay.
We got 2 questions. First one, we've got a situation where auto-parameterization kicks in, and essentially you lose visibility to what values were passed in with the query.
Can you speak up? I'm sorry, I'm having a tough time hearing.
All right, you're going to make me say auto-parameterization again, but when it kicks in, you essentially lose visibility to the actual values that were passed in with the query, the actual qualifiers in the where clause, for instance. If those qualifiers were very selective, such that you said where column A equals 1 and it was a very selective versus any other value, do you still take that into account in determining the execution plan? So if your where clause would have been very selective given the values, but it's not very selective given the auto-parameterization.
In the first case, and I did mention that the server is very conservative for auto-parameterization, and it needs to deterministically, based on the statistics, the schema, determine that the number of result sets are probably going to be equivalent for each use of that parameter, and if not, it's not going to parameterize, auto-parameterize.
Okay. Second question, do you have a recommendation on whether you can get any significant gains by turning off or turning no count off during the execution of a multi-statement stored procedure?
I'm really sorry, I'm having a tough time hearing.
Okay. Do you have any recommendation on turning no count off during the execution of a stored procedure? Is that really going to get you significant savings?
I actually don't have a recommendation on that, I'm sorry.
Hi, Filo.
Hi, Lexi.
I have a question. Is there any situation when stored procedure can be bad because of CPU load on server side? We have fat client, and we can use a lot of CPU on client side, so potentially we have more load on server if we use more stored procedures.
Yeah, if I understand your question, but you're still going to have to do all the processing for round trips and shifting the initial query results back to the client to put the logic on and send a subsequent query back to the server. I think you'd want to test that, but in most cases, I think you come out ahead actually implementing the stored procedure.
Okay, thank you.
Thank you.